Okay, example 2, moving on to a trigonometry equation, f of theta equals sine of theta. Again, that same question, they're asking me to find absolute, local, maximum, minimum values of this function from 0 to pi. Okay, so theta is our independent variable. They're giving us a restriction on theta that theta has to live between 0 and pi. It's including 0 and including pi. So we're inputting theta, we're going to output f of theta. So the x value is theta, the y value is f of theta, for the sake of graphing. Now, if I'm graphing trig functions and it's dealing with radians, which this class we're going to deal specifically with radians, we're going to use degrees in this class. So anytime you see trig functions in this class, make sure your calculator is set to radians if you have to evaluate. All right. If I have to evaluate a bunch of radian values between 0 and pi, I want to go with some pattern in my picks. All right. Sine itself, we already know that sine of 0 is equal to 0, and sine of pi over 2 is equal to 1, and sine of pi is equal to 0. We already know that stuff, right? Those would be some, I guess, maximum, minimum value type things going on there. So we know some specific spots that occur. So where the parabola, we want to find the vertex with sine, we know that the most it can ever hit is positive 1, the least it can possibly hit is negative 1, 0 somewhere in the middle. Those are some special values there. All three of those numbers lie between 0 and pi. All right? But I want to get a little bit more accurate graph than just 3 points. So what I'm going to do is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's go by pi over 10 scale. Okay. You can go at any scale you want to go. Every one of my dashes represents pi over 10. All right? If I graph based on that scale, I'm going to type in y equals sine of theta, in this case sine of x. All right, I don't know what sine of pi over 10 or sine of pi over 2 pi over 10, which is pi over 5, or 3 pi over 10, and so on is. But my calculator does, and I can do it this way. I can just type in all those numbers individually. But since we're going to go on a pattern, I'm going to do it this way. I'm going to go second, table set. Okay, you're going to set up your table. I'm going to automatically set the x's. And the way we do this, I want to start at 0, because that's my starting point, right? I want to go up by pi over 10. That's delta table. So pi divided by 10. It automatically figures it out. You don't have to figure out what pi over 10 is. If you type pi over 10, it'll give as many decimal places as it can. I'm going to turn independent onto auto. We usually are on ask. Ask means I get to put any number in I feel like. Auto means I'm going to let the calculator put them in for me. It's going to start at 0 and go up by pi over 10 at a time. All right, if I go to my table now, it will automatically be set up. And you can see here, pi over 10, 2 pi over 10, 3, 4, 5, 6, 7, 8, 9, 10 pi over 10, also known as pi. All my values are sitting there right in front of me. Dang. So just like that, I've got everything I need for my table. And I can even do this to make my job even easier. There we go.
Can I do that?
There's my explanation. I don't think you can, but... All right. As far as graphing is concerned, a couple decimal places is plenty. Okay, again, that's obviously more than I needed. So if this is you guys filling out your papers, I would go 0, pi over 10, pi over 5, which is 2 pi over 10. If you don't want to reduce, that's fine, 5 pi over 10. But even better than the pi over 10 and stuff, because that's exactly what it is. You know, you got 0.31, you got 0.63, that's fine. If I put in the pi over 10 and stuff like that, keep in mind this is 1 pi over 10, 2 pi over 10, 3 pi over 10, because that's what I scaled this at, right? So again, when I put a scale of pi over 10, each one of those dashes is pi over 10. As far as the y's are concerned, 0.31, 0.59, 0.81, 0.95, and so on. So keep that in mind. Don't go out 50 decimal places when you're graphing. I mean, it's
How many?
Just a couple decimal places is plenty.
How many points should we do? Just 3?
I'd do all of them.
Oh, we do all of them?
Let's graph all of them. We can. Got my numbers here on top there. Okay. So as far as y is concerned, it starts at 0, goes up to 1. And I got a bunch of dashes here, right? 1, 2, 3, 4, 5, 6. Let's go y to 0.25 scale. Again, just for the sake of, the smaller you make your scale, the more detail you can put into your graph. If you make the scale small, the graph gets bigger. If you make the scale big, the graph gets smaller. Whatever you do to the scale, the graph does the opposite. Alright, so again, if I just made it at, let's say, a pi over 2 scale, 0 pi over 2 pi, and a 1 scale, it just looked like this. That's not very detailed, alright? So by making the scale smaller, I'm going to get more points and kind of blow it up and zoom in. So 0, 0, pi over 10 is 0.31, which is a little bit over 0.25. Then we get 0.59, which is a little bit over 0.5. Then 0.81, which is a little bit over 0.75. Then 0.95, which is almost 1. Then we get 1, then we're at 0.95, 0.81, 0.59, 0.31, and 0. Just like that, we get all these points, and we get this nice sine graph, like so. So again, sketch the graph by hand. Endpoints themselves have to be considered as open or closed circles. Always do that when you're graphing. I can see equals to on both the 0 and the pi, which means right here, equals, equals. So both of these are closed circles, so both those points actually exist in the real world. Okay. Notice they're exactly the same number. Okay. Even though there's two bottom numbers, they're both the absolute minimum values. Okay. And the way we handle that when there's multiple absolute minimums is we say absolute minimum of 0 at x equals 0 comma pi. Okay, the minimum value occurs multiple times. Tell me what it is and all the x values where it occurs. And in fact, instead of x equals, it should be theta equals because that's the variable they gave us. And we can see here this is the absolutely highest point on the graph, right? So I know the absolute maximum of 1 at theta is equal to pi over 2. I'd rather get pi over 2 than 1.5708. So if you just go, there's 1 pi over 10, 2, 3, 4, 5 pi over 10. That reduces to pi over 2. I'd rather have the exact value than the approximate value when you, if you're capable of doing that. In most cases you are. So once again, no calculus involved here. I simply use my calculator to graph. I use my eyes to see the highest and lowest points, identified what they are. Okay, so everything you're doing right now is going to be based on your skills in other math classes you've had so far.